Hello, pre-algebra students. In your Unit 1B polynomials packet, you'll see next up we have some exponent rules, and we will use these in much more depth in the algebra class, but want to introduce those to you now. And so first off, if we are multiplying and the bases are the same, then we can add the exponents. Right? So, and we won't typically see that x in there. A lot of times we'd see a times, like a dot or something, because the x is, going to be used more and more for multiplication, not for multiplication, but as a variable. Oh. So, and so even if that A is any number. So for instance, the example over to the right, 3 to the 4th times 3 to the 5th, we do 3, keep the 3, keep the base the same, and then 4 plus 5 to make 3 to the 9th. So the part that's written below probably just happens in your mind. At this point, I'm not asking you to evaluate yet, just rewrite it with a single exponent, okay? So if you do go ahead and then say it equals, I don't know what 3 to the 9th is off the top of my head, but let's say the 4 to the 2nd one below. If you want to go ahead and give me the answer as 16, you could, but I do want to see 4 to the 2nd, all right? So I don't want you to I want to know that you know the rule, okay? So when we're dividing, it should make sense that if we're dividing and the bases are the same, we can subtract the exponents. And we're going to do that because remember that division is the inverse operation of multiplication, and subtracting is the inverse operation of addition. So if you get one of those, the product rule, we call that product rule, the one about multiplying, and then it's quotient rule, the one about dividing. If we want to simplify a power of a power, so we're raising a power to a power, then we multiply the exponents. And then anything raised to a negative exponent is the reciprocal of it being raised to the positive exponent. So basically we turn it into a fraction and put a 1 on the top. And then the exponent becomes positive. Any number raised to the power of 1 is just that same number. So we don't, if we see that, then we can just rewrite it as the same number. But anything raised to the power of 0 is equal to 1, not 0, 1. And we'll talk more in class about why that is, but think about something divided by itself, like 5 divided by 5 is 1. 5 divided by 5 is not 0, 5 divided by 5 is 1. And so we've worked a little bit with exponents before. We know that the large number is called the base, and the exponent is that small raised number. And so this would be 5 to the power of 3 or 5 to the 3rd power. Okay, so remember we could also say to the 3rd power, or 3rd power has a special name, cubed. You can call that 5 cubed. And so here we're not going to get all the way to the final answer. We're just going to simplify to have only 1 exponents. So product rule, when we're multiplying and have the same base, we're going to add the exponents. So we keep the 2, add the exponents. 4 to the 3rd times 4 to the 8th, 4, add the exponents. This would be 5 to the 10th. This would be 8 to the 24th. So even though they're the same, we still add those exponents together, but the base stays the same. And 2 plus 5, 3 to the 7th. So since when we're multiplying, we add the exponents, again, only if they're the same base, those base numbers are the same. When we're dividing, we are going to subtract the exponents. And hopefully that makes sense since we know that those are inverse operations. Again, to use the rule, the bases must be the same, which we see that they are. So this would be 2 to the 7th. Or I could say 2 to the power of 7, or 2 to the 7th power, or simply 2 to the 7th. 3 to the 1st, which is actually also just the same as 3. 5 to the 6th, 7 to the 10th, 4 to the 3rd. So all of those, I'm just subtracting top, subtract bottom. Next up, we're going to raise a power to a power. I call this the power rule. But it does mean we are raising a power to a power. So again, we're going to keep the base, and we're going to multiply those exponents. So notice the difference between this and quotient rule. With quotient rule, it would have looked like this. There would have been, the base is the same, but there would be two bases. Now, it's like the exponent is on the exponent. All right, so there's no other base in between. Just the 2 and the 5 both up there up top. So now we're going to multiply. So it's not the same as that. So 3 times 4, 5 to the 12th. 21. So I'm just multiplying the exponents. So I keep the base, multiply the exponents. Keep the base, multiply the exponents. That one might be kind of confusing because all those, so many sevens. And then negative exponents. When you have negative exponents, you're going to take the reciprocal of the base. All right? So we don't ever want to leave an expression with negative exponents. And so it would not be considered simplified if it has a negative exponent. To get rid of the negative exponent, the base and the exponent go to the denominator. We put a 1 on the top so that it looks like a fraction. Once it's down in the bottom, we could think of it as it's happy there, right? It's positive once it gets there. So this is 1 over 3 to the 2nd. This would be 1 over 5 to the 7th. I'm a little tight on space here, sorry. 1 over 9 to the 9th. So once I do 1 over, then the negative is gone. 1 over 2 to the 10th. And 1 over 12 to the 8th. Now, if there happened to be, a little bonus thing here for you, if there happened to be a negative exponent that was in a denominator of a fraction, to get rid of that negative exponent, it would go to the top. So for instance, if I had 1 over 5 to the negative 3rd, then to get rid of the negative exponent, the 5 to the 3rd would come to the top. And since there would be nothing in the bottom of the fraction, then it's not a fraction anymore. And you might say, what happened to the 1? Well, 1 times 5 to the 3rd is still 5 to the 3rd. So another time when we have to use this rule, remember quotient rule, on quotient rule, if I had something like 4 to the second divided by 4 to the fifth, well, I would get 4, 2 minus 5 is negative 3, but we can't leave it that way. That's not simplified. So then I would say 1 over 4 to the third. Now, I'll tell you a little secret. Little secret is, since you always have to simplify it, if when you see this, you ask yourself, where is the higher power, the higher exponent? Oh, it's in the bottom. Since it's in the bottom, it's going to be on the bottom. And then do 5 minus 2, there, and then we have to put the 1 on the top. So then you never have to write this part in the middle. Both ways, final answer 1 over 4 to the third. Just a little added something something there for you. Okay, there are some special rules for zeros and ones. Any number to the first power is that number itself. Okay? Any number to the first power is that number itself. So 5 to the first is 5, 3 to the first is 3, 17 to the first, 17, 9. So for that reason, we don't see first power very often because it is just the same as the number itself. When raising 1 to a power, it doesn't matter what the power is, the answer is always 1. Think about it. No matter how many times I multiply 1 by 1, 1 times 1 times 1, it's still 1. Still 1. And then anything to the 0 power, anything to the 0 power is always 1. So anything to the 0 power is always 1. The only exception to that is that 0 to the 0 power is undefined. 0 is kind of a special guy. But 0 power is just a 1. All right, so then coming up after that, you have some practice to do with exponents. So you're going to give the answer and tell which rule or maybe rules you used. So maybe there are more than one rule that you would use. The what you should say for the what rules did you use is something from these. All right. So for instance, in number 2, if I subtract the exponents, I would get this, and that would be quotient rule because I divided. But I cannot leave it that way because I can't leave a negative exponent, and then so I would call that the negative rule. So even if I did it in one step and thought about there's more on the bottom, then I would still say I use the quotient and negative rule. And if you left off the word rule, that's okay. It's just giving us which rules we're using. Okay, so that's what's meant by that. So you have a little bit of practice there, and then there will be an IXL lesson. The IXL lessons that I am assigning, you'll see with the star under your recommendations, and those are going to be D9, 10, and 12. All right, so this is one of them. This is power rule, and you will just be typing the 9, and then this would be multiplying the exponents, so 9 times 6, 54. Remember, in any of the IXLs, if you're not sure what to do, you might see the little video to help you. Or before you answer the first question, it will give you a chance to learn with an example. But these are the ones I assigned are the same rules that you just went over in your packet. So should not be a problem. Again, they will be at the top of your recommendations list. All right, great. Thanks.